I'm going to help you with number 101 here and 102. I'm just going to get some of this writing off of here for you. So you're supposed to be sketching in number 101 the velocity mile. Sorry, the velocity graph. And so we've got time. And over here we're going to have velocity along our y-axis, v of t, or you might want to call it miles in miles per hour. Basically, I'm going to be charting the speed of my car. Sorry about that. So anyway, in the first 2 miles, first 4 minutes, we went 2 miles. So if we can go 2 miles in 4 minutes, what that means is we must be going 30 miles in 1 hour. That makes sense because you'd multiply by 15 to go from 4 minutes either way. Or you might even want to think of the old distance equals rate times time model, where I went 2 miles and I'm figuring out how long it took me when I went. It took me, in 4 minutes, and I want to know how fast I'm going. And 4 minutes is 4/60ths of an hour. You could reduce that to say 1/15. And then you'd still get 30 miles per hour is equal to your rate. So what that means is in the first 4 minutes, I've been going, let's just call that a 30 miles an hour. Well, then what happens in the next 2 minutes on this graph is my distance isn't changing. I'm still sitting there at 2 miles away from my house, which means I must have stopped. Maybe I stopped and went to the bathroom or something, but I made it 2 miles and then I'm not getting anywhere. It's still 2, which means on my velocity mile, I must be going 0 right there. Maybe I stopped to go to the bathroom, so I was going 30 to get to the edge of town, stopped at the edge of town to go to the bathroom, and then what happened in the next 4-minute interval? Well, in the next 4 minutes of this trip, what happened, let's go out here to 10, in the next 4 minutes of this trip, it looks like I went 4 miles in 4 minutes. Well, what does that mean if I went 4 miles in 4 minutes? Basically, I'm going a mile a minute, or 60 miles an hour. So you go up here to 60, and you would simply go like that. So, if you're kind of considering what this trip looks like, I'm going 30, and then I stop, and then I'm going 60. What this graph doesn't give you is kind of any acceleration or anything like that, but this is how you see them in physics quite a bit. So let's go look at the next one where we're going in reverse. Well, now I'm being given my velocity or my rate in this context, and I'm trying to figure out how far I went. So in the next one, I would still have my time down here along my x-axis, but on this one, I'd be looking for my position or my distance in miles. So I want to know how far I'm traveling on this one. Well, let's see what happens in the first time interval, which is in the first 6 minutes. So let's go out here to 6. And I am going 40 miles per hour for 6 minutes. So again, if you want to think of your distance is equal to rate times time, I am going 40 miles per hour for the first 6 minutes, or 1/10 of an hour, which means I will have traveled 4 miles by the end of that 6 minutes. So I'm going to go up here, maybe call that 4, and I'll just draw a bar. What happens in the next bit here? Well, it says that I'm not moving. Well, if I'm not moving, then I'm still going to be at 4 miles. So in the next 2 minutes, my position will still be 4 miles into the trip. And then after that, what happens in the last two minutes of this trip is I'm going 60 miles an hour, and I'm doing that for 2 minutes. So if I'm going 60 miles an hour for 2 minutes, which would be 1/30th of an hour. You could do 2 minutes, 2 over 60, it doesn't really matter. I will have gone 2 more miles, which would put me at the end of this trip at 10:06, or in 10 minutes, I've gone a total of 6 miles. Here's where I started. After 6 minutes, I'd gone 4 miles. In the next 2 minutes, I hadn't moved at all. And then after 10, I went 6. So these are more the physics models of these. You won't be doing a whole lot with it, but I thought for those of you in physics, maybe it'd be kind of an interesting little twist on the calculus.